In this video, we'll rationalize the denominator with the second flavor of fractions. In the first video, we looked at fractions where there was just one term on the denominator, but now in this second video, we'll look at two terms in the denominator. The goal is to still get the radicals out of the denominator, but they go about it in different ways depending on how many terms there are. So when there's two terms on the denominator, we have to use something called a conjugate. And the conjugate is basically like an opposite, but in a special sort of way. So if you have x minus 1, then the conjugate of the square root of x minus 1 is the square root of x plus 1. If we have, let's say, 2 plus the square root of y, then the conjugate will be 2 minus the square root of y. It even works if you have coefficients. So you could have 2 plus 2 square roots of y, and then the conjugate will be 2 minus 2 square roots of y. Now the whole goal is that we create a almost like a difference of squares. If you notice that we have the same terms at the beginning and the end, but the signs are opposite. So if you think about going back to factoring and multiplication, when you had the same values, opposite signs, this is how you would factor a difference of squares. So we're just artificially creating a difference of squares because squaring numbers, like squaring square roots, takes you back to a plain number instead of a square root. So let's do problem 1. Let's take 8 and divide it by the square root of 5 plus 2. So to rationalize this denominator, again, we're going to use the same tool of multiplying by a version of 1, but this time 1 is going to look like the square root of 5 minus 2. And then also on the numerator, square root of 5 minus 2. So we'll go through and multiply. Be careful to use parentheses on your numerator so that you distribute the 8 correctly, because we don't want 8 square roots of 5 minus 2. We want 8 times the quantity square root of 5 minus 2. We'll come back in a little bit and clean that up. On the denominator, we have the square root of 5 plus 2, and then the square root of 5 minus 2. So if we go through and FOIL out this denominator, I'm going to write this in the next step. We have the square root of 5 times the square root of 5. So a square root squared is the plain number. So the denominator starts off with 5. And then, so we'll do first, and then we'll do the outer. So minus 2 square roots of 5. And then we'll do the inner. So then we'll add 2 square roots of 5. And then lastly, we have the last. So positive 2 times negative 2. So we have a minus 4. And then on the numerator, I'm just going to keep this as 8 times the square root of 5 minus 2. And I'll see if I need to change anything later. Okay, so I have multiplied my original fraction by a version of 1. I did the FOILing on the denominator to get rid of the parentheses. And now I can start simplifying. Now we do this conjugate on purpose because notice these two middle terms. They're the same number but opposite in sign, so they actually cancel each other out. They are like terms and they add to 0. So our denominator is now 5 minus 4, and that numerator is 8 times the square root of 5 minus 2. All right, now we can simplify a little bit more. 5 minus 4, well, that's just 1. So 8 times the square root of 5 minus 2 divided by 1, anything divided by 1 is just itself. So let's actually just write out 8 times the square root of 5 minus 2. And now we'll distribute. Sometimes I like to save this distributing on top for later, just in case I can simplify and I already have a factor. In this case, my denominator disappeared, so I can go ahead and just multiply 8 times the square root of 5 and then minus 16. So I'm distributing right here. So now we have our answer, which is 8 square roots of 5 minus 16. So what started off with as a fraction with a rational number in the denominator, a radical number in the denominator, ended with no radicals in the denominator. All right, let's try a second problem. 17 divided by the square root of 10 minus 2. All right, so first step, we need to come up with our version of 1. I will use the conjugate of the denominator, so keep the same values, but switch the sign in the middle. So 10 square root of 10 minus 2 is now square root of 10 plus 2. Put that on the numerator so that our value of our answer is still the same. It's just going to look different. Now I can go ahead and multiply because, I can put the parentheses in there and show that this is all multiplication. 17 times the square root of 10 plus 2 all over square root of 10 minus 2 times the square root of 10 plus 2. All right, so denominator, couple sets of parentheses. I need to do my foiling to get an answer. So big fraction bar, let's start foiling the denominator. Square root of 10 times the square root of 10 is going to be 10. Now I'll do the outers, so plus 2 square roots of 10. Now do the inners, minus 2 square roots of 10. And the last, minus 4. On the numerator, 17 times the square root of 10 plus 2. So there's a number of middle steps of these problems. You might have noticed on the last one, I could have distributed the 8 earlier on. In the middle, the order in which you simplify and combine, it kind of doesn't matter. I could spread this out into, 20 different steps if I really wanted to, by doing little tiny bits at a time. Sometimes I scoot through the simplification a little faster, sometimes it's a little slower. In the end, it doesn't really matter. There's lots of little steps you can do one at a time, or you can do a bunch all at once. Just don't go from, answer or starting problem to answer. That's too many steps that are skipped. Okay, so back to my problem. I have 17 times the square root of 10 plus 2 all over. Now I go back, and this should always happen if you've correctly chosen the conjugate. You will always have the middle terms with the radicals cancel each other out. So that's the whole purpose of the conjugate, is to get this canceling out to happen, and then you end up with just a number and a number, which can be easily combined. So 10 minus 4 gives me 6. Let's write that a little bit nicer. 6. Okay, so I'm going to look at this problem. Is there anything I can simplify? So I held off multiplying the 17 through the parentheses because I could look to see if 6 and 17 have any common factors. They do not, so I'm going to go ahead and distribute this 17. 17 times the square root of 10 plus 34, and all of this can be divided by 6. And there we go, we have rationalized the denominator there are no more radicals in this denominator. Let's do one more problem. Let's bring some variables into the mix. The square root of x minus 2 divided by the square root of x minus 5. So what makes this problem different than our last problem is that the numerator before was just a single term. Now we have two terms. And I've actually brought in some variables as well. So start off, let's create our conjugate. Square root of x plus 5, and then the square root of x plus 5. Now, I'll point out that when we rationalize the denominator, I look at the denominator to determine the conjugate. There's something called rationalizing the numerator, and so you'd look at the numerator to create the conjugate. The rationalizing of the numerator is not as commonly done. It's mostly because we don't like to have radicals on denominators. We're not as concerned with radicals on the numerators. So you might have noticed that pattern on the denominators when we were foiling out. It always seemed to be the first term squared, stuff canceled out, and then the last term squared, and there's always a minus sign. So we can quickly rationalize this problem, at least work on the denominator, by knowing that this square root x is going to give us an x. The 5 times the 5 is a 25, but always put in a minus sign. And so basically I have foiled the denominator. Here's the parentheses that I was foiling with, and I could quickly get an answer. If you don't trust that this works, go ahead and foil out each step, first, outer, inner, last. Now the numerator is a little different because it's a minus 2 and a plus 5. I could foil the denominator really easily because it was minus 5 and plus 5, but when you have different numbers, let's go ahead and write out this a little bit slower. Square root of x minus 2 times the square root of x plus 5. So I'm still going to foil, I just have to go a little bit slower and look at each term. So as I am foiling, root x times root x, that gives me x. Now the outer, root x times 5, so plus 5 square roots of x. Now I'll do the inners, minus 2 square roots of x, and then the last, we have minus 10. And the denominator stays the same, x minus 25. Now let's go ahead and simplify our numerator. The denominator, nothing to simplify there, so I'll just keep writing x minus 25. On to our numerator now. I have a plain old x, and I don't see any other x's, so I can't try to combine my like terms. But the middle terms, those are like. They both have square roots of x. We have 5 of them that are positive, 2 of them that are negative, so we end up with a plus 3 square roots of x. And then my last term is negative 10, and it just hangs out. There's nothing to combine there. So at this point, this is our answer. It's not quite as clean and pretty as some of the other ones, but there's nothing else that I can reduce. You can't split this up very well. Don't try to cancel x's or 10s and 25s. That only works when you have factors. These are all 3 terms, and this is 2 terms. You can't do any simplification with just the terms. So we leave our answer just like this.